Hello everyone, and welcome back to our channel. Today, we have an exciting topic to discuss: Azure Serverless Computing. In this video, we'll dive deep into the world of serverless computing and explore the incredible features and benefits it offers on the Azure platform. So, without further ado, let's get started. What is serverless computing? Before we delve into Azure Serverless Computing, let's quickly recap what serverless computing is all about. In traditional computing, you need to manage servers and infrastructure. But with serverless computing, you can focus solely on writing code and delivering value to your users. The cloud provider takes care of provisioning, scaling, and managing the infrastructure, allowing you to concentrate on your application's logic. Azure Functions is Microsoft's serverless compute service, and it's an essential component of Azure Serverless Computing. With Azure Functions, you can execute code in response to events or triggers without worrying about infrastructure management. Whether it's HTTP requests, data changes in storage, or a scheduled timer, Azure Functions has got you covered. In addition to Azure Functions, Microsoft offers two powerful services that complement serverless computing: Azure Event Grid and Azure Logic Apps. These services enable you to build event-driven architectures and create powerful workflows by connecting various Azure services and external systems. Azure Event Grid is a cloud-based event routing service provided by Microsoft Azure. It plays a crucial role in enabling event-driven architectures and building reactive applications by providing a scalable and efficient way to route events from various sources to interested subscribers. At its core, Azure Event Grid follows a publisher-subscriber pattern. Publishers are the sources of events, such as Azure services, custom applications, or third-party services. Subscribers, on the other hand, are the endpoints that are interested in receiving and reacting to those events, such as Azure Functions, Logic Apps, webhooks, or custom HTTP endpoints. Azure Logic Apps is a cloud-based service provided by Microsoft Azure that allows you to create and run automated workflows and integrations. Logic Apps provide a visual designer that enables users to build workflows by connecting different actions, triggers, and connectors, without the need for writing custom code. These workflows can integrate and automate processes across various systems, services, and applications. Serverless computing offers several benefits that make it an attractive option for many developers and organizations. Here are some key benefits of serverless computing. Cost efficiency. With serverless computing, you pay only for the actual usage of your application or function, rather than provisioning and paying for idle resources. This cost model eliminates the need for upfront infrastructure investments and allows for more granular cost control. Serverless platforms automatically scale resources based on demand, ensuring optimal resource allocation and cost efficiency. Scalability and elasticity. Serverless platforms automatically scale your application or function based on the incoming workload. They handle the scaling process transparently, allowing you to seamlessly handle spikes in traffic or processing without worrying about capacity planning or infrastructure management. This enables your application to scale rapidly and handle varying workloads efficiently. Reduced operational overhead. Serverless computing abstracts away infrastructure management tasks, such as server provisioning, patching, and maintenance. Developers can focus on writing application logic and functionality without the need to manage servers or infrastructure. This reduces operational overhead and allows teams to allocate more time and resources to building and improving applications. Increased development velocity. Serverless platforms provide a faster development cycle by removing the need to manage infrastructure and allowing developers to focus on writing code. The event-driven nature of serverless architectures promotes modular and decoupled designs, enabling teams to develop and deploy components independently. This results in shorter development cycles and faster time to market for applications. Automatic high availability. Serverless platforms typically offer built-in high availability and fault tolerance. They handle the deployment of your application across multiple availability zones or data centers, ensuring that your functions or applications are resilient to failures. This eliminates the need for manual setup and configuration of redundant infrastructure components. Event-driven architecture. Serverless computing is well suited for event-driven architectures, where functions or applications are triggered by events from various sources. It allows you to easily integrate with event sources such as message queues, databases, storage services, or HTTP endpoints. This enables you to build reactive and scalable applications that respond to real-time events. Some common use cases of serverless computing include web and mobile backends. Serverless architectures are ideal for building lightweight, scalable backends for web and mobile applications. They can handle user authentication, data processing, API integrations, and other backend services without the need for provisioning or managing servers. Data processing and analytics. Serverless platforms can be used to process and analyze large volumes of data. Functions can be triggered by data events, such as file uploads, database changes, or message queue events, to perform data transformations, aggregations, or enrichment. IoT, Internet of Things. Serverless computing can be utilized to process and respond to events generated by IoT devices. It allows you to handle device telemetry, perform real-time analytics, trigger actions based on sensor data, and integrate with IoT platforms. Chatbots and voice assistants. Serverless architectures are well suited for building conversational interfaces, such as chatbots or voice assistants. They can handle natural language processing, intent recognition, and integrate with messaging or voice platforms to provide interactive and responsive experiences. Event-driven automation. Serverless functions can be used to automate business processes and workflows based on events. For example, you can trigger functions to send notifications, process orders, initiate approvals, or update databases based on specific events or conditions. Real-time stream processing. Serverless platforms can be employed for real-time stream processing and analytics. Functions can process and analyze streaming data from sources like event hubs or Apache Kafka, enabling real-time insights and actions. These are just a few examples, and serverless computing can be applied to a wide range of scenarios where event-driven, scalable, and cost-efficient. That concludes our journey into the realm of Azure Serverless Computing. We covered the basics of serverless computing, explored Azure Functions, Event Grid, and Logic Apps, and discussed the benefits and use cases. With Azure's powerful serverless offerings, you can build highly scalable and cost-efficient applications with ease. Thank you for joining us today, and we hope you found this video informative. Don't forget to like, subscribe, and share this content with others.